Okay, so let's take a look at what happens when we plot a sequence. So right now what I have plotted is f of x is equal to 5 times sine of x. Okay, so here when we're plotting a function, what I'm looking at for my x values are real numbers. So all real numbers, or at least all the ones that are in the domain for that function. Okay, so we get a nice continuous looking function here in our graph. You can actually change your calculator to sequence mode by switching the mode and going over to where it says sequence. Then you have an older style calculator like mine. You also need to change the connected to be dots. Okay, so you'd make those two changes. Some of the newer calculators, I think you just need to switch it to sequence. Okay, so I push the y equals menu. This first line here is asking you for the starting value of n. So I'm going to start my n at 1. And then what I plotted was 5 times the sine of n. Okay, and so when I look at that graph, what I get is a series of dots. Okay, so my n are natural numbers, so my function is not continuous here. Okay, I just have a bunch of individual dots or individual points. And so that's going to affect some of the things that we're going to do. And the first thing we're going to actually look at doing is finding the limit of a sequence. And for most of the time, we can just find the limit by applying our limit rules. But we'll talk about what to do if there's kind of a little bit more difficult situation there. But let's start out with the basics. So the first thing we're going to do is define what it means when your sequence has a limit. So a sequence has the limit L, okay, which is written as the limit as n goes to infinity. So all of these we're going to look at as n goes to infinity of a sub n is equal to L. So here's L, and here's a sub n. So here's our function. It's kind of bouncing around for a little bit, and then it seems to settle down right around here, around the value of L. Okay, so there'll be kind of a little window where your sequence values will be hanging out at, but eventually they're going to settle down to be pretty much close to L, if not exactly L. All right, so the reason we're interested in the limit of a sequence is that that's going to tell us whether our sequence converges or diverges. So we would say that a sequence converges if the limit as n goes to infinity of a sub n is either exists or is finite. Really is kind of the key thing we're looking for. Okay, so if it doesn't exist, you're done and it diverges. But we need it to exist, and we also need it to be finite. We would say a sequence diverges if the limit as n goes to infinity of a sub n either does not exist or it's infinite, either positive infinity or negative infinity. And in either one of those situations, we would say that the sequence diverges. So two examples for you here. Here is the sequence n plus 4 over n plus 1. And we can see a bunch of these dots have been plotted that it seems like this is settling down to a value of 1. Okay, in this figure here, the sequence cosine of n has been plotted, and so you can see all the dots moving around here to kind of make our up and down motion for cosine, but it doesn't ever appear that it's settling down to one value. So this sequence is going to diverge here.